Assalamualaikum, this is Laiba Masood, and today we will be discussing the topic of Argand Plane. So let's slide the slideshow. Before discussing the topic of Argand Plane, we need to know that why do we need to study complex number, okay? This is a myth that imaginary numbers have no real world uses. I mean, most of us think like that imaginary numbers have no real world uses, but in reality they have a vast number of uses in our daily life. They're mainly used in signal processing and data transmission and much more. They are also used in mechanical design and other things. In 1940, a minor gale hit a Tacoma bridge, and suddenly it started swinging, and then drastically it collapsed. And you know what was the reason behind this collapse? The engineers messed up the imaginary part of the equation, and that was the reason. So I guess you know now that how significant complex numbers are. So if you see any meme that it's another day without using complex numbers or quadratic equations or anything like that on internet, so it is completely wrong. This is a wrong idea, because most of us, means Gen Z, cannot even imagine to spend a single day without Wi-Fi or internet. Am I right? Okay, then we will proceed to how can we represent complex number graphically. As you all know, we can represent real numbers on a number line, but that is not the case with the complex numbers. To represent the complex numbers graphically, we use an Argand plane like this, and the Argand plane is this. Okay, in Argand plane, the vertical axis or y-axis represents the imaginary numbers, and the x-axis or the horizontal axis represents the real number. Let's say we have a complex number z equals 2, 3 plus 2 iota. So where will we plot this? 3 will be plotted like that, and 2 it will be plotted like this. I hope you get the idea. Let's look at some more example. So here we have an example of complex number, which is 2 plus iota. Okay, we have the real part positive, that is positive, and the imaginary part is also positive, so we know that it will lie in first quadrant. And then we have another complex number, which is minus 2 plus iota, and we can clearly see that the real part is negative and the imaginary part is positive, so we will plot it in the second quadrant. And then we have another complex number which has negative real part and a negative imaginary part. It will be plotted in third quadrant. And then we have another complex number which has a positive real part and a negative imaginary part, which is 2 minus iota, and it will be plotted in fourth quadrant. So first quadrant, we have positive real part and positive imaginary part. Second quadrant, we have negative real part and positive imaginary part. In the third quadrant, we have negative real part and negative imaginary part. And in the fourth quadrant, we have positive real part and a negative imaginary part. Can you notice something about these two numbers? Yes, this number is a conjugate of this number, 2 minus iota, and we know that in the conjugate what we do is we change the sign of the imaginary part. Here we have plus iota, and here we change the sign and it is minus iota. So it is a conjugate of that number, and you can clearly see that how conjugate number is, is like a mirror reflection of its original number. Its direction is changing, the magnitude remains the same, only its direction is being changed. So that is it for today's video. Hope you will like it. Allah Hafiz.